Welcome back, my Algebra 2 students. We're in lesson 55. We're going to talk about advanced abstract equations first. This is a three-parter. We remember that equations that contain many variables and have no numerical answer are often called abstract equations, right? So we use variables instead of actual values. And we remember that when an equation has rational terms or fractions, the solution is facilitated if we begin by getting rid of the denominators. So to solve an equation like this, all that to say, a over x plus y over m, that is not a plus sign, Tracy, hello, plus y over m equals c, we would have to find a common denominator, right? So we would multiply everything by the common denominator until everything has the same, can be put in the same terms. So because this is an equation, we can eliminate the denominator in the long run. So we do that by saying, what's our common denominator? Well, that's going to be xm, right? So if we multiply this top and bottom by m, we get am over xm, right? Same thing here. We multiply this by x, we get yx over xm. All right, get the x added. And if we do it by this one, we get cxm over xm. Thus, we can eliminate our denominator because it's all common. And if we were to multiply everything again by xm, we would get am plus yx equals cxm. And then we could subtract yx from both sides, and we get am is equal to cxm minus yx. And then we would be able to factor out the x. To solve for x, we would say am equals x times cm minus y, right? Then we could divide both sides by cm minus y, and we would get am over cm minus y is the value of x. So we can use these abstract values. We don't have to have a single coefficient in order to solve for any specific term that we designate. So we could say, I want to solve for m. We could do the same thing for m. We want to do C, we could do the same thing for C. What we have to do is isolate, well, C is already done for us, but you see what I'm saying. All we have to do is decide which one we want to isolate and then figure out how to isolate it. But, we put it all of that one term, everything that has that one term on the same side, and then we factor it out, and then we divide by the opposite factor, which in this case was cm minus y, both sides. We divide by that on both sides, and then that allows us to cancel and isolate the term we wanted to isolate, which in this case was x. So the same procedure is used for even more complicated equations, and parentheses sometimes help us to avoid mistakes when we do that. So we are going to solve for, we're going to do 55.1 and 55.1. Let me move my book, it's in my way. All right, 55.1, we are going to solve for m. That's the one we're solving for. And here is the problem. We have a plus b over x. And then we have y plus y over m equals k. So we're going to use the same type of logic, which that's what this is. This is logic. We're just moving numbers around in a logical order to define a value for a specific or a specified one, a specific one. So let's solve for m. So first, we're going to find a common denominator, which in this case is xm. So xm is our common denominator. So let's look, we need to multiply this by m. So we have m times a plus b over xm, right? Plus, we need to multiply this by x, so yx over xm. And we need to multiply this one by both, so we get kxm over xm. And now that they have a relationship, they all have the same denominator, we can eliminate it, right? Go away. So we have ma plus, I'm going ahead and doing my distribution now, times mb plus yx equals kxm. Remember, we're solving for m, so we need to take yx and move it over here. So minus yx equals, and we need to get xm over here because we want to find that m, right? So minus, I don't know why I said equals here, it doesn't go there, minus kxm. We're going to subtract yx from this side as well, and we're going to subtract kxm from this side as well. So this cancels. So now we have ma plus mb minus kxm equals negative yx, right? All right, so now let's look at factoring out m. So we have m times a plus b minus kx equals yx. We divide both sides by this, a plus b minus kx. Same thing over here, a plus b minus kx. Then we get that m is equal to, this is negative yx over a plus b minus kx. All right, we see how that kind of works. It's all about just isolating that one value, that one variable. So let's do another one, and I want you guys to try this one, see what you get. This is 55.2. And we are going to solve for x. All right, and this is our problem. We have MP over C plus D plus E over X equals D. And I was not looking when I wrote the X, and that is pretty obvious. So X. All right, this is an E. All right, it's not a badly written C, it's actually an E. And I'm going to actually try to write this a little bit better. D plus E, there we go, over X. So let us solve for X. So what I want you to do is pause the video, solve for X, and then press play and see if we got the same answer. All right, you should have gotten that X is equal to C times D plus E, or CD plus CE. If you went ahead and did the distribution, that's fine, over DC minus MP. All right, if you've got this as your value of X, then you did this correctly. If you did not, let's walk through it. So the first thing we did was we found our common denominator, which was CX. So we multiplied CX times each fraction. And basically what I'm doing here, this is a shortcut. I am multiplying what's missing. What's missing is X, but I'm doing it in such a way so that it is standard all the way across. Because the C's cancel each other, I'm only multiplying X times MP, which would give me C over X, but because these two cancel, it goes ahead and eliminates the denominator. So you can get rid of the denominator. It's the same step, but you're doing it all in one step, not two steps like I was doing. Same thing I was doing, just writing it a different way. In this case, the denominators cancel because you have X and X, so you're just multiplying this by C because you already have the X here. And in this case, there is no denominator, so it's just CX times D, which is what you would have had here. You would have had X times MPX over CX, and then you would have this over CX, and then we would have eliminated all the denominators as the second step. This just does it all in one step. So it's however you need to think about it. If you can do it all in one step, that's fine. Do it all in one step. If you need to do the two-step, do the two-step. It's up to you. All right, so now what we ended up with was MPX plus C times D plus E equals DCX. We subtracted MPX from this side so we could bring it over here to the other X, which was already on this side, because that's the least amount of swimming that we would have to do. You always want to do the least amount of swimming because it's easier to keep the numbers straight if you don't have to move them all around. So that left C times D plus E on this side, which you could have distributed. Didn't matter. You could leave it as this. It's the same answer. Okay. So then we factored X out of this side over here, which gave us X times DC minus MP. And then we divided both sides by this factor here, DC minus MP, which gave us the answer of C times D plus E over DC minus MP equals X. So if you got this, or if you got CD plus CE over DC minus MP, either one of those is correct. I just didn't distribute that because I knew it wasn't going to affect X at all because there was no X involved in this. All right, 55.3. We have one more like this, and then we'll move on. Let's just get one more good practice in. Let's see if we can solve this one. This one we're going to solve for A. And we are going to do mx over y, remember to write as I write, plus d over a plus b equals p. We have quite a few variables in this one. All right, we're solving for a. So step one, we find our common denominator, which is going to be y times a plus b. That is our common denominator. So we're going to multiply everything by that. So y over a plus b over 1 times mx over y plus y times a plus b over 1 times d over a plus b equals p, let me do that again. Y times a plus b over 1 times p over 1. All right, the y's cancel, which leaves us mx times a plus b plus a plus b cancels, dy equals py times a plus b. All right. Now, in order to solve this, we have got to we've got to go ahead and distribute because a is one of our terms in this distribution, and that's what we're solving for. So we have to simplify it. So in order to simplify it, we have to distribute it. So this is going to give us mxa plus mxb plus dy equals pya plus pyb. Now we can put the a's together. And this would, if we put them on this side, we'd have to move 2. If we put them on this side, we'd only have to move this 1. So let's do that. Let's do minus mxa minus mxa. Actually, let me write that over here so it's easier. Minus mxa. Now we're going to subtract this, minus pyb minus pyb. All right, so this cancels and this cancels. Now we rewrite it. So we have mxb plus dy minus pyb. All right, equals pya minus mxa. So now we can do some grouping. Let's do mxb plus dy minus pyb equals, let's get a isolated, a times py minus mx. All right, you see how we pulled a, we factored a out of each one of these, and that left us with py minus mx. Now we can divide both sides by this factor, py minus mx, which makes that cancel. So now we know that this is equal to a. So we rewrite that really nice and neat, mxb plus dy minus pyb all over py minus mx equals a. And that is this in terms of a. That's what we mean when we say in terms of. We mean, what does a equal? What are we solving for? We're solving for a, so it's in terms of a. All right, so let's talk about word problems and quadratic equations. Fun stuff. All right, sometimes, we have a word problem. I'm going to clear the page. Sometimes we have a word problem where the solution is an exponent of 2. And the only way to solve that is to treat it like a quadratic equation where we could set both sides equal to 0, and then we end up with 2 possible solution sets. So let me type 55.4 in here so we can talk about that, so you can see it. So give me just a second. All right, so here's 55.4. Find 3 consecutive integers such that the product of the first and the third is 4 greater than 4 times the second. So we would write that out. As always, we begin with the integers as n. So we have n plus 1, and n plus 2, right? So there's our first, second, and third integers. So we start with that. Now we write out the equation. The product of the first and the thirds, that means the first times the third. Okay, that's the product of that. Is 4 greater than 4 times the second. 4 greater than 4 times the second, which is n plus 1. All right. So 4 greater than 4 times the second. Now we solve. And we get n squared for the first time. We haven't seen that before. And then we get plus 2n equals 4 plus 4n plus 4. All right, so now we squish and flip. And we get, this is 8, so we're going to subtract 8 from both sides. We're going to subtract 4n from both sides. So minus 4n minus 8, right? So that, we bring that over here, and this cancels this, and this cancels this. So that means we have 0 over here, and we have n squared. This is a negative 2n minus 8. All right, we're going, because we have this exponent of 2, we have to treat this like a quadratic equation. We can't solve it another way. So we're going to now factor this the way we would a quadratic equation. So we have 2 sets of parentheses equals 0. So we have n times n is the only way to get n squared. And the factors of negative 8 are going to be a it's either going to be a positive 4 and a negative 2, or it's going to be a negative 4 and a positive 2. This gives us a positive 2 as a result. This gives us a negative 2 as a result when we combine those. So this is the one we want. So we want negative 4 and positive 2. All right. So now now that we have this, we can set them both equal to 0. We can say n minus 4 equals 0. So n would be equal to 4. Or n plus 2 equals 0, so n would be equal to -2. So we have two sets of consecutive integers here. We could have either 4, 5, and 6, or we could have -2, -1, and 0. All right, as our result. So that is something to think about whenever we do one of these word problems and we end up with an exponent of 2 on one of our variables. We can treat it like a quadratic equation and get two possible answers for our consecutive integers. All right, that is all we have for lesson 55. I will see you guys in lesson 56.